So what we're going to look at now, given the graphs of some exponential and log functions, working out what the rules are for them. Okay, so the examples I'm going to look at are just taken from the yellow textbook in section 5F. So this is the first example we've got. We have here, we can see that it has 2 points, which are the y-intercept and another point, 322. We don't know what the horizontal asymptote is, but we can work that out in due course. We know that the equation is given by this particular form. So when a question gives you the form, you know exactly what you need to find. Okay, we have two unknowns, A and B, which, given the graph that we have here with 2 points, we can use those 2 points to find those two values that are unknown by using simultaneous equations. So first of all, substituting our y-intercept here of y equals 6 and x equals 0 into the equation form that we have, that allows us then to write one equation here at 6 equals a plus b, because this term here conveniently becomes 1. The e to the 0 is 1. The other equation that we have using the other point, 322, y value of 22 and x value of 3, that then allows us to have our second equation. And because we have two b values with the same coefficient, we can just use the elimination method and subtract equation 1 from equation 2, so that we end up with 22 minus 6 equals 16. E cubed times a minus a will give us e cubed minus 1, being the new coefficient, okay, because the coefficient of this a here is 1. So when we combine them together by subtraction, we get e cubed minus 1. The b's will cancel. B minus b equals 0. And then just rearranging that, we have a equals 16 over e cubed minus 1. What we can then do is substitute out this a value into this equation that we have here. And so we have 6 equals 16 over e cubed minus 1 plus b, and then rearranging to solve for b will be 6 minus 16 over e cubed minus 1. And what we'll do then, going from here to here, is just combining these as a single fraction. So we need to have the same denominator, so we multiply the 6 by e cubed minus 1 over e cubed minus 1. And so we have just a single fraction now, 6 times e cubed minus 1 minus 16. If we expand this and collect our like terms, we end up with 6e cubed minus 22 as our numerator, all over e cubed minus 1. So this is our expression for b, or our value for b. And then if we go up here, we can put both our a and our b value into our function form y equals a times e to the x plus b. So we have 16 over e cubed minus 1. That gets multiplied by e to the x. So the e to the x we can just put in the numerator with the 16. And then plus our b value that we have here. Okay, not a very nice looking function by any means, but as long as we're working through accurately, this is what we have. Okay, so we can see then this actually would be the equation for the horizontal asymptote is this value here, 6e cubed minus 22 over e cubed minus 1. Okay, so that's our first example, and next we'll look at another example using log functions.